everyone, and welcome to this walkthrough video. And in today's video, we're gonna go over the GitHub repository of LUKSO lsp-smart-contract for the Code4Rena audit contest. So I'm gonna give you a walk through the structure of the folders, the contracts present in there, and some basic commands that you can use to go work on the repo for auditing the contract. So yeah, let's get started. So you can see the code of the lsp-smart contract under this repository, which is what we are going to have a look over. So if you go into the repository, first of all, you will see multiple folders. And the main folders that contain the contract are the contract folder and the submodules. So if you go into the submodules, you will see there is a submodule called ERC75, which is basically the ERC75 repository. So it is set up as a dependency in the main repository. It has an npm package, but for the purpose of Code4Rena, it's installed as a submodule. So if you go over the contract, you will see overall different type of contract. You will see different folders specific to each LSPs, each standard. So each of these folders contain the core contract, the core implementation of a LUKSO standard proposal. And we'll have at the root folder the universal profile smart contract, which is the LSP3 standard, and it's the blockchain-based account that represent a universal profile. So overall, you will see there are three different types of contract. There are contract that start that end with nothing, just the name of a standard. So for instance, if we look at LSP0, you will see there is LSP0 75 account, and then we have the contract that finish with core, init, and init abstract. So the difference between those are, as explained in the repo, in the README, you will see the explanation. I think it's here. It's under the scope section. So there are three main types of contracts. There are contracts that are defined with core. So these are the contracts where there is all the core logic. So if you look at, for instance, LSP0 or 75 account core, you will see all the actual core logic of each function. So for instance, the core logic of a batch call function, or the execute function from ERC75X that use LSP20 under the hood to do the call verification. You have set data with all the core logic as well. So the core contract contains all the core logic as the name suggests. Then you're gonna have contracts that are what we call standard contracts. These contracts, they don't end with anything. It's just the name of a standard, and they basically inherit the core contract. And as you can see, they are deployable through. They are deployed with a constructor. So all the initial parameters to be set on deployment are set through a constructor. And then you have the init contract. So the name of the standard finished by init, and these are the proxy version of the base proxy contract version of each standard. So they contain a public initialize function, and they act as a base implementation that can be used behind the proxy. So they have a constructor that is that basically lock the base contract on deployment, so that you cannot initialize the base implementation. And they have an initialize function that is the function that proxies will use to initialize their actual contract. In the test, we use mainly EIP 1167 minimal proxies, which are 55 bytes long for bytecode, and contains inside the bytecode the address of the implementation. So the address of the implementation inside the bytecode, it's this contract that is deployed. So it's one contract form. The main difference in summary is standard contract for if you want to deploy a universal profile for 100 users. If you use standard contract, you deploy 100. You deploy 1,000 contract. If you want to use proxies, you use the init contract. You just deploy one base implementation, and you deploy 1,000 proxies that have the implementation address linked to this unique contract that has been deployed. And overall, you will see over file in each of the folders for each standard. In general, it's structured the same way. There is it always starts with the LSP and the number of the standard, and you have things like constant .so. So these are all the constant value defined per standard. So as an example, if I go into the lsp4 digital asset metadata, if you go to lsp4 constant, you will see that these data keys are the data keys related to the lsp4 standard, and they are defined in the lsp4 standards. So if we go to the repository of the LIP repository, you will see, if you go to the lsp4 digital asset metadata, we see that all these data keys, these ERC75Y metadata keys that are defined here, these are the data keys present in the constant file. So if I search here, you have lsp4 supported standard key, you have a token name, a token symbol, the lsp4 metadata. So any metadata standard, the values are defined in this file. As an example, we can look at LSP3, and you can see the metadata key LSP3 profile. If you want to find this metadata key in the repository, you simply go to the LSP3 universal profile folder, and you'll see there's just lsp3 constant.so, and you have the data key for this. So aside of the constant file, you also have things like a file called utils and errors. So utils, any file called utils, it's basically a library contract, and it basically serves as a reusable function across multiple files. So it's function that you can developer can use to build their own implementation, so that it do all the heavy lifting for them, or it's used also mainly across the standard to fetch to basically do some common interaction. As an example, you have get permission for. It's mainly used across in the key manager, and it's just a utility function that construct the data key address permission, which is defined into the LSP6 standard. So if you look at the metadata keys of LSP6, you will see that there are address permission, and basically this function perform all the create the data key for the data key mentioned here, where the address will be the address of a controller that is replaced, and it will fetch the permission for this address. Same for alert call, same for get allowed ERC75Y keys, same for has permission, same for checking if the data is valid. So all the files that ends with utils are libraries. Any LSP something util.so is a library contract that has reusable flow function. The main library are LSP 6 LSP1, LSP5 for generating the assets keys, LSP10 for the vault keys, and you have also I think LSP2, and there are few functions in scope of audit for LSP2. You also have across in the files listed a file is called lsp called errors.sol. So as an example, if we go at lsp14, if we click on lsp14 errors.sol, you will see the errors that are used inside the inside the core implementation. So as an example, all the custom errors defined here are used and triggered into this into the implementation contract. As another example, if we look at LSP7, any errors defined here are going to be used and triggered into this contract, into the core implementation. Another last point that it's good to be aware of is that most of the standards have the interface defined in them. So if you look, for instance, here on the left side, you will see lsp6 key manager has an interface file called. They all have an interface, and it always starts with the I and the name of the standard. So ILSP6 key manager, ILSP7 digital asset, you have ILSP14, ILSP0, and if you look at this interface, you will see it's an interface contract that is inherited by the core contract, as you can see here. Sorry. Actually, this one inherits the implementation, but ILSP, for instance, ILSP0, LSP0 survive account core, implement the interface, so implement all the functions inside the interface. And in general, the interface are the actual interface defined in the standard. So we have here LSP6 open. You will see at the bottom of each standard, each of the standard specification, an interface cheat sheet with all the functions defined in the interface, and you will see that these are the same that are defined into the interface file, and they are in general documented, so they contain the standard event defined in the standard. And they are documented with what this function is supposed to do, and the implementation is in the core contract. And that's pretty much it for the contract folder. The second part that I'm gonna give you a walkthrough over is the test folder. So the structure is the same. You have the test for each standard grouped in its own folder, and you basically have tests that are split in between the .test.ts and the .behavior.ts. So if you look, for example, the .test.ts is the one where all the context is built and all the implementation of a contract are built. So as an example, universal profile is an LSP0 ERC725 account. As you can see in the diagram into the README, it implements multiple modules and interface. So these tests, any .test.ts build a context and basically check the behavior of a specific module under used by this contract to ensure that each module separately work when implemented into the standard. And you have same for the init version. The only difference is that there is the base implementation contract being deployed. You have the minimal proxy being deployed, and then it's attached. And then it's basically attached to the implementation and initialized. And the same thing happened. We build the context for each module, and we test the behavior of each module separately on each implementation. So overall, for the folder, this is how they are separated. You will see also in the utils folder all the helper file that we use for basically building the different context. So these are helpers and fixtures. You have things like deploying the fixture for deploying the proxy, fixture for deploying a UP with a queue manager and setting it up, and you have fixture for deploying a UP with a key manager with a universal receiver delegate. So for doing the full setup and the full universal profile architecture here. And yeah, these are basically what is used in our test. And if you want to really dig into the actual tests, we can look, for instance, at let's say lsp6 key manager. If you look at lsp6 key manager.behavior, you will see the key manager. For the key manager is quite big, so we splitted them into multiple. We splitted the test per permission. So all the tests related to the permission, change owner, change or add controllers, or all the tests related to the permission set data are in their own file. So you will if you click on these sections, you will see the actual unit test being read, being built, and being covered. In general, you will see, for instance, for lsp7, the same thing happened. You have a standard and the proxy version for the normal contract and the extensions, and you have the behavior.ts, which is actually all the unit tests. So all the unit tests for testing when minting tokens, when transferring tokens, the decimal, the authorized operator function, etc., etc. So if you want to dig into write extra tests, you can do that. Here. And finally, you have also a set of Foundry tests, which are located here. So you can install Foundry. I will show you in a minute, and you can run the test around Foundry in these. You can run the Foundry test defined in all these files here. Yeah, Foundry test for LSP2 and for the gas benchmark. So yeah, for the gas, I will show you in a minute. You can have you have two sets of utilities for you have two ways of benchmarking for the gas. You have Foundry gas benchmark here for different type of interaction, and you have tests from the benchmark test.ts, which are defined here. Finally, so to continue, we have, if you want to look a bit in detail, you have a doc folder which have all the developer doc for the contract. So if you look at any of them, you will see the generated doc for each of the method. But in general, they are better read on docs.lukso.tech. You can find them in two places, in standard smart contract, and if you click on the file, you will see the list of all the function and the explanation. And we are in the process of migrating these these standard ABI docs, and you can find them. You will find some of them also in this section. At the moment, there are only 2. You also have a folder called deploy, which contains a set of script for deploying profiles. So if you want to, for instance, run proof of concept, if you want to run proof of concept in your local hard hat node or on a test network, you can do that by running the script. You just have to specify a private key under the hard hat config or .env, and you can run the script and it will deploy the contract for you. And if you want to see how it works, you can do that inside the README. You will see all the command for deploying, and yeah, you just have to basically specify in your hard hat config the private key to be used under the for deploying. I think you can do that actually. Here. So yeah, if you have a .env config and you specify a deploy key, you can then have a script. You can basically use this for deploying. Okay, I will then finally give you a walkthrough of the final section for as you can see, there is a list of known issues, and you can find the list of known issue in 2 places. First, if you click on the table of content, you will see under the audit folder about several reports. These correspond to audits that we made in the past on the smart contract. So you can go into the audit folder and you will see each report in PDF, and you will be able to go through the report to look at the previous findings. And finally, you can go into the sliver known issue. So if you go from the top, you will see under automated findings publicly known issue, the last bullet point, sliver known issue, and this is available in the stop sliver folder. So if you will see that it's this folder sliver, and all the known issue that we are aware of on sliver are located on each markdown found per contract. So yeah, you can find details about this one here. So finally, I will show you quickly few points. So first, regarding the UP and the key manager, I just wanted to show this little flowchart to explain to give a high-level overview of on the key manager of what's the main path that the key manager can interact with. So you can interact with set data and set data batch. It's not mentioned in the screen, but there is also set data batch. Execute for execution, and then you have transfer ownership and accept ownership. So when a universal profile on or an LSP0 ERC75 account is linked to a contract, it is linked to a key manager contract, and the key manager has this path allowed through it. Bear in mind also that what we are interested is to test different type of architecture. For instance, a key manager linked to a token contract. So a token contract that has multiple that can be controlled by multiple entities. So the permissions of this controller are stored on the token contract, and the key manager is the gateway through the to interact with the account. Yeah, you will see all the details here under this under the overview section. And overall, for the one main thing about the token contract, in terms of how they are similar, is the function for transferring assets. They have a very similar transfer function. The aim is to unify the interaction. The only difference is that LSP7 for the fungible token use an amount, while LSP8 use a token ID to transfer. And they both notify the LSP1 universal receiver of a recipient. And if you want to, by default, this is set to false, meaning that the recipient is a contract that has to implement the LSP1 standard in order to be notified and aware that it has received assets. But if you want to enforce this behavior to not necessarily be LSP1 recipient, you can set this boolean to true and transfer to any contract. It can be an externally owned account, or it can be any other contract that implements or not LSP1. I will quickly give some overview on the basic command. So for running the, first of all, for installing the contract, you'll see the quick start section. So you simply have to clone the repo, go into it, and you have to install all the submodule. So the submodule, so meaning ERC725 and Foundry. So if you instantiate them like that, and then you run npm install, this will install all the submodule, and this will install all the dependency from the package.json. So the OpenZeppelin library, all the hard hat and chai for the test, and then you can go into you will have to go into submodule ERC725 implementation, and you will have to do the same, npm install. And once this is set up, you can go back to the core of the repo. So for building, you can just simply run the npm run build command. This will compile all the contract. So it will generate the artifact and compile all the contract. And for the test, what I will recommend to do is there are a lot of tests. So if you run npm run test, all the tests are going to run. It's going to take a lot of time. So if you are doing testing, I would recommend to go into each test file and either mark the test as .only to run only the specific test, or to test on a per standard basis. So we have, if we go into the package.json, you will see we have tests for each set of standard. So for instance, if you do npm run test :lsp1, you are going to run all the tests related to the lsp1 standard. So all the tests related that are located in this folder are going to run only these tests, and it's in general quicker and easier to work with. So we have the test for LSP1, LSP2, LSP4, LSP6, the token, and when the tests are marked with init, it's for the init implementation of a contract. The tests for the UP are and the lsp0 are all under test:UP and test:UP init. So yeah, you can see it's a bit it's a bit quicker. We also have a test around gas benchmark. So if you do npm run test:benchmark, you will see that some tests will be running, and it's gonna output the result into a markdown file called benchmark.markdown, and you can preview this file here, like here, and it's gonna give you back the gas usage for some common interaction. So for instance, when the universal profile is on by an externally owned account, or when the universal profile is on by a key manager and has multiple controllers. So if you are looking around for gas and comparing the usage, you can do that this way. Finally, we can go over the command for running the foundry tests. You can do that using npm run test::foundry, and this will run all the foundry tests, and it will also output a gas report in this ANSI file. So it's going to do all the foundry tests and the phasing. And yeah, finally, you can go over to give an overview. You can do about the LSPs and the smart contract. The idea of these contracts is to be the building blocks really for the new creative economy. So we intend to have this contract used as a modular contract that they can be built to build different architecture. And the intent is to use this package and build in the same way as you will use the OpenZeppelin contract repo as components and building blocks to build your own protocol or application. And we are in the process at the moment. We have more. We are having more interest and contribution into the LSP repo. More standards are the idea is that we have more standards being proposed, and that their future implementation for each new standard are added into this repository. And finally, if you want to learn more about the LSP standard, you can watch these videos or LSP standard workshop that we did in our previous hackathon. And they are fairly detailed, and you will learn really in detail each LSP standard, the background ideas, and it will give you a very comprehensive understanding of each of the standards. And yeah, that's it. I hope you enjoyed the video. I hope it helped you get going into the Code4Rena audit contest. Thank you.